Hi everyone. Little abrupt here that I'm making a new video and it's been like a couple years and now all of a sudden we've got this. So let me give a quick intro. This is tying in with a podcast called Advent of Computing, which if you already watch it, that is super cool that there is that overlap. But we're both, pretty not huge fan base people. So the odds of those overlapping, if you're one of those people, let me know. That's crazy. But me and my friend Sean, who does a podcast called Advent of Computing, which is a super cool kind of just coverage of a historical computing topic every 2 weeks, decided to get together and do a kind of video podcast thing, just chatting about his previous episode on alternate weeks. So we're calling this Adjunct of Computing, and we're just going to see how it goes. And since I already have a channel, I will be posting the videos here. So the first thing you should do is go over to the Advent of Computing site so that you can listen to the episode that we will be talking about. It is the episode on RSX, which I believe, relative to this video, is going to be 2 podcasts ago. You'll find it, I'm sure. I don't have the episode number off the top of my head because I am just not a prepared person. But anyway, that's what this is. So me and Sean are going to have a chat here about RSX 11 and just computer history things in general. I thought it was fun. He seems to have thought it was fun. It seemed to go pretty good, and we think we're going to keep doing these. So hopefully you enjoy this as well. The only thing I want to add, because I didn't get to do that when I edited the original episode, is the end actually cuts off a little early. You wouldn't know if I didn't tell you, but it's just such a bummer because my mic stopped recording for like the last 15 minutes of our call, and I think there were a lot of cool topics that we covered that just didn't make it in. So I just wanted to let you know because that makes me sad, even though you would never know if I didn't tell you that. So without further ado, here's 2 nerds talking about RSX and also a bunch of unrelated stuff. Please enjoy. On that note, let's start this episode. So hi, you will have never seen me before. My name's Joe. I do run in the, vintage computing world circles. You'll see me at VCF Midwest a fair amount. I'm not a very big player, but you may have spotted me there before. I've had a booth for the last few years, so maybe some people know me from that or my small-time YouTube channel that I don't know. Perhaps this will also go up on. I haven't decided. We haven't decided. We're flying by the seat of our pants here.
It's exciting.
Hi.
It's new.
Yes. So I twisted Sean's arm here because every time I listen to an Advent of Computing episode, and I feel like surely I cannot be alone in this, I leave it excited about the topic and wanting to look up about 500 ancillary topics about it, and also to turn to Sean and go, okay, surely, there's only so much you can dig into in about like 45 minutes, an hour of talking about a subject. So I want to know more detail about these things. And also I want to press you on some topics that like you research stuff, so you definitely know about, but me as a layperson listening am going to be like, no, Sean, I don't think that's right. Let's argue about that. And I think that will be a good gestalt therapy for people listening.
There is value there. I will say, Joe, you didn't really twist my arm that much. This is an easy sell for me, especially since, like you were saying, you listen to an episode, you want to go learn more. I know I jokingly say I leave things as exercises for the listener, but I actually mean that, right? Like if you're listening to an episode and you're like, ooh, I would like to learn more about object-oriented programming. Good. That means I'm winning.
Yes. And then you need to go check out the Smalltalk 80 Blue Book from your local library. You can get it. It's a hoot. It's a hoot to read. All right. So anyway, that's the idea, is we're going to have these little post shows, or, we're going to see how that goes. So with that said, I think I'm just going to toss to Sean for a quick recap on what we're talking about. This week's episode was RSX 15, 11, all of the precursors and where it might be going. I know pretty much anybody who's going to watch this will know what's going on, but just for those people who decided to tune in just for this strange episode, what were we talking about, Sean?
So, last episode on Advent of Computing, we were talking about the RSX series of operating systems, which, as you alluded to, the name game is kind of frustrating. This is very much one of those topics where it's like, oh yeah, there's 10 names. They're unrelated. They're just randomly numbered, or randomly lettered in this case. RSX was a real-time operating system written first for the DEC PDP-15 and then ported, as in rewritten, for the PDP-11. And there were maybe a dozen different versions. I talk about 6 of them on the episode, but there are more that are very poorly documented that just kind of exist. Where it's going, though, is this year I want to talk more about DEC, and I want to eventually talk about VMS. And whenever I look at doing VMS, well, you have to talk about RSX 11 or 15 because that's the immediate precursor to VMS. So you kind of can't do one without the other, and RSX ended up being interesting enough that it definitely warrants its own episode. There's so much technical detail in the manuals and so much to the story that it was great. It's one of the times where I don't have to fill in a lot of gaps. I just got it all.
Yeah. Oh man. It seems like the further back you go in time, just the better the technical information gets, because you go back far enough and you get, like, I don't know if I feel like you would be the kind of person who have you ever seen like the UNIVAC technical manuals?
Yes.
For like the original UNIVAC?
Yeah.
Those are a hoot, because it's just like, here's how the thing works, here's the wires. And a lot of the old DEC manuals are like that too, because I printed and bound my own copy. This is already getting way off the point.
That's unavoidable, right?
It really is. The PDP-4 user manual, because I want to build one. That's a whole
PDP-4.
It's and now I may be screwing that up because it may be the 5. It's either the 4 or the 5. Yeah, I think it's the 5. It's the immediate precursor to the PDP-8.
Gotcha.
So it was, they originated that architectural idea with DEC system modules, and then decided to make a version with the flip chip technology that they used in the PDP-8, which is just that family of cards. Anyway, so it's a relatively simple system, and I really want to build one. That's on my to-do list. Anyway, but that's great too, because those old DEC manuals, they just have, here's how you build the computer.
Yeah.
But yes,
what it turned out with the manuals for RSX is, and I talked about this on the show, I'm going to talk about it again because it surprised me. They are so technically detailed. Like you go to one of the first few pages in the RSX 11M manual, and it's talking about like data structures and how to do addressing and the actual like bit packing in a table, which I don't expect that in a manual. It's nice to see, but you don't expect that at all, right? Especially these days.
Right. No, it's fascinating, and it's super cool that you get that extra information. The thing that I think we haven't mentioned yet that actually piques my interest the most in this is the RTOS aspect of things.
Oh yeah.
Because we mentioned the VMS link, but you kind of lead it in. I mean, that's again kind of the conceit of the episode, really, is that it comes in with the RTOS and then it leaves as this is going to be the precursor to VMS, like you were saying. But I like the RTOS angle in that. And I think maybe I'll touch on this and we'll come back, because actually I want to talk a lot about RTOS stuff. Is that it really brings into the question, what is an operating system? And it kind of that mushiness of the definitional aspect of operating systems there, which I think especially for when you're talking about old computer junk, the what is an operating system question is actually a really deep historical thing. Yeah. Because you get, I mean, like anybody who's ever read, especially like a programming manual from like the 80s or early 90s, it's going to talk about, well, here's your batch processing and then your interactive time sharing stuff. And so it leads one to dig further into that, lineage of operating systems being a actual thing, when especially, early computers, it's not a thing. You don't need one. You're writing software for the computer.
Well,
but at RTOS,
it's interesting because the first operating system developed at GM was for batch processing. It was so they could have a binary that would be fed in initially, and then you'd hand the computer a job card and then another binary to run, and then a job card and another binary, and the operating system would keep it running. But that's that looks nothing like an operating system we have today, right?
Right.
There's no interactivity.
But it is funny because you can see how like that leads to the command line, right? Because it just is, but presented as a different format. But with RTOSs, to back it up to that one, I've always been interested in that. You talk about the whole aspect of this having originated from the idea of a software factory, all of that kind of stuff. And one of the things that I always thought was interesting, particularly when I started getting into how does an operating system actually work as like a young, someone learning how to program, is that an operating system, you can really think of it to a large extent as like a library, right? It really is. You can think of it as a library that plugs into your program to give it system services. And RTOSs to a certain extent, like really are the logical extreme of that, because I was double checking because I'm not an expert on RTOS stuff, and especially like modern embedded.
Oh yeah.
But there's
Neither
like,
am I.
I looked up, yeah. But I know enough to be dangerous about, vaguely around the area.
Precisely.
And that a lot of RTOS systems boil down to you write your task and this RTOS is a bunch of libraries that you link into your thing to provide services for your, embedded application.
Yeah, it'll
either. So I double checked because like embed, which is one that stuck out in my mind. It's basically got the option. You can just link it as like a set of libraries, or you can run it as NOS, which basically means that it has a tasking model, which again, that's a whole thing to get back to. But yeah, go ahead, please.
Yeah, like you're saying, it will either be you get a package of library services that you link in, or what's interesting with RSX is it's a very, very early microkernel, which that's a whole nother topic, right? But that
is a whole nother topic.
Such a lightweight system that it basically gives you just tasking, very low level IO primitives, and in some cases memory management, kind of. RSX doesn't really want you managing your memory, and how it does it, like it has partitions. You have these fixed windows that your program gets to live in, and you can request like a couple bits and bytes on top of that. But doing so, because that's a call back into the system, right? That can lead to weird, well, not weird in the normal operating system sense, but for RTOS where you're trying to always execute in the same amount of time, that can lead to an unknown amount of time to request space. Right. So you kind of really only want to use it for task switching and IO primitives, which is so different than like Windows or Mac OS or Unix, which gives you everything.
Right. And it's that takes me back to that's the RT of the RTOS thing is kind of the tasking model, right?
Yes.
Because of course if you've got like a library style RTOS, you are as fast as you are writing your code for, right? Either whether you're pulling or you yourself have registered your interrupts. Whereas with the RTOS, it's providing those systems, and like you were saying with registering tasks in RSX and hooking your task, if that was the right term, because terminology was a big one here. But like assigning your task to an interrupt handler, there's going to be the constituent code of the RTOS that's going to sit between you or the interrupt happening and your stuff getting called, and that's where the RT of the RTOS lives. As an aside, we're going to give off on so many tangents. I apologize beforehand to everyone. We already know. Apologies will be given again, but this is just going to be tangents, the show, which I think is honestly that's probably exactly what I mean in the show. But
the main show is so much not tangent that this is better. We get the depth first search and then we get the breadth search, right?
There it is.
It's a compliment.
Wow. That's an analogy. But so another thing, because maybe I'll aim for like bullet points off the top of things that strike me as I listen to the episode, and then we can revisit them. Is I don't know why, not that I'm super deep. I'm not a super deep deck person in the first place. And I'm particularly not like, I don't have almost any experience with like PDP era hardware, software, anything. I have a little bit with VAX and a little bit with VMS, but So RSX in general is this thing that I'm vaguely aware of, in that it pops up every now and then. You know, if somebody's talking about deck stuff, it'll come up, because you've kind of got those two worlds, right? You've got the deck Unix world and then the deck world, and that's like a very
first party
the story of deck.
Party.
Yeah, and so you've got RSX as their operating system, and Unix is the
well, it is kind of striking how associated deck and Unix are because of the 11, because deck wasn't really doing first party Unix stuff. I mean, there are some connections later on, but it's not like, here's deck Unix, you can buy Unix from deck. That was never a thing. So it's interesting. That must have been, I'm sure I could dig up some writing, but that must have been a very kind of weird vibe at deck, having your killer app be Unix, right?
Yeah, so to get back to the thing about RSX is that because of that, I've been vaguely aware of it, and I've only really been vaguely aware of it as an operating system, like a general purpose operating system. Mm-hmm. And I know I've read the wiki article on it before, but I didn't really latch onto the fact that it's called real-time system executive. Mm-hmm. And I like this part of the story because just tracing it through from, this was industrial controller type application,
completely
that's totally headless.
Right. You're not supposed to touch it. You create your program and you walk away. The computer is running now. It's not for you to run on.
Mm-hmm.
And then it
totally, anybody who knows embedded is going to know that paradigm. But it's unusual for just like your normal computer user. And again, as someone who's just thinking of here's cool computers, I'm thinking RSX, and I'm seeing, Dave on Usagi Electric. He's, messing with his PDP stuff, and he pulls up RSX, and I'm like, all right, so it's just like their operating system. But that is such a interesting lineage to start off as. I mean, particularly, like, there's that question of what makes an operating system that we will get back to many times, but it's that, if it's this set of services that you can build an application on, and you can have so many tasks, why not just make one of those tasks a user interface task? And now all of a sudden it's like a usable operating system. And that's really the only difference between, I mean, besides the fact that your timing is different.
It's because usable for a different thing.
Yeah.
Right.
Okay.
Because I'd say that the question of what's an operating system is less about capability and more about just the simple fact that an operating system is something that manages computer resources.
Right.
Because when you strip it,
and I think on this, it's the question of like, on whose behalf? Is it on a user's behalf, or is it on your industrial job's behalf, your embedded job's behalf?
It should be on the program's behalf. As a programmer myself, the OS, and I've done a lot of operating system development back in the day.
And we'll get to that too.
Ooh, not
it's on my list.
Effect.
We'll get back
to very poor effect, but it's a fun side project. But anyway, the way I view it is an operating system just manages resources on behalf of a program, right? Because at the end of the day, you can have a program that's interactive or one that's not interactive. The user just kind of enters on the periphery, on like the squishy interface, right? So RSX is doing, like RSX 15, really early versions are doing everything that Unix does, kind of, right? Because it's managing how memory should be doled out. It's managing like race conditions and who gets access to what hardware, like peripheral hardware, and it's managing time because it slices up execution time. And when you strip everything away from Unix, like all the nice stuff that we love, that's also all Unix does. It's just that there's all these other features built on top of it.
Right.
I mean, maybe the original operating system is just the cleric in the computer room that runs your cards and decides, oh, it's Tuesday at 5 p.m. Sean's program goes in next for 30 minutes. That's an operating system. It's just not a software operating system.
Right. Yeah. So I don't know. The one thing that I also want to dive into
Yeah.
And then I think finally that pause leaves me to go, yeah, I think we can start diving back into some of these topics finally. Because I'm just searching for what were the other things I wanted to ask. I want to get them off my chest up at the top. And one was, you enter with bliss, you exit with bliss, and you say this had nothing to do with bliss.
Yes.
But the thing I have to ask is, again, you're going to get a lot of, we're both developers, is our professional background. This is my understanding. So you're going to, I think, also get a lot of that perspective. Less, I think the IT, there's the two big perspectives, which is the infrastructure guy and the software guy. And for infrastructure guys, we're sorry. We're both software guys. Maybe if we keep this going, we'll get an infra guy in here at some point.
I work with a lot of infra guys, and they're very nice to me. I buy them beers when I see them. But yes, we are adjacent. I'm adjacent, but definitely very, very software centric.
Yeah. But so Bliss.
Yes.
I guess just my leading question on Bliss is, it just makes me want to ask, have you ever used Bliss? And I feel like, because you seem like you're the person, just listening to your episodes, you've done a bunch of, I don't want to call Bliss an SO-lang, because it's not an SO-lang. It's just at this point, it's an SO-lang. But I was curious if you ever poked with it, because Bliss is one of those things, again, with my dalliances with VMS, I am aware of Bliss, and I have that same inkling and interest that you portrayed of yourself, where it's like this weird C competitor, and there's a handful of those things at the time, right? Like PLI.
Gotta learn more, right?
Bliss. I mean, Pascal obviously goes in there. But so, yeah, I got to get it installed and play with it sometime. I want to know.
Here's the funny thing. There is a modern Bliss compiler. The reason I opened and closed with Bliss is the first thing I read about RSX is, oh yeah, it's a real-time operating system. It's written in assembly language and some Bliss. And immediately I'm like, yes, please tell me more. It turns out, like I said in the episode, Bliss doesn't come in till much later, like the 1980s, which is beyond where the story ends on the show. But as to using Bliss, I have, and I forgot about it. So when I was working on this episode, I kept trying to jog my memory about Bliss syntax, and I was looking around on my hard drive for the computer that I do all my research on, and I found a bunch of Bliss code I wrote. Not a bunch, like maybe 100 lines. And so I was able to jog my memory. When I had done my Bliss episode, I was playing around with the modern compiler. I don't think it's LLVM targeted, but it like works on modern 64-bit machines, runs under Linux. So is this like an open source thing, or is this it's open source,
a commercial? Okay.
Yes, completely open source. Download it today. I forget where I downloaded it. I think you can just look up Bliss compiler.
Link below.
Maybe. But I had been trying to get LD to properly link a binary to a Bliss binary, because in my head I'm like, oh well, it's a systems programming language. I should be able to do like a Hello World bootstrap loader in Bliss.
Yeah.
And I gave up at some point. I can't remember why. I assume it's because I'm very bad with LD and I couldn't quite get the object files to link properly.
LD's a beast, especially if you're trying to do things that, like,
oh my god,
if you were saying you were doing like a bootstrap program,
you have to be super careful with.
Yeah.
Bliss, though, the compiler outputs ELFs, the modern compiler, so you can just run it, which is neat, but not quite as neat as doing a Hello World that's linked to like a bootloader.
Well, I mean, it's a systems programming language. You got to use it for systems programming.
Exactly. Yeah. And I'm not going to write a compiler in a weekend. That sounds awful.
Yeah. I might be tempted to, but no. I'm like for the third time in the middle of writing a Lisp. So
man,
I'm busy.
I'm for like the 8th time in the middle of writing a small kernel again because of this episode. So I know where you are. I understand.
Yeah. So let's go to that, because let's go to the personal interest angle of things, because of things you mentioned. You've brought up, I think, a couple times. I've dabbled in a couple operating systems, by the way, and for those who are curious, me too. If you want to look at my bad code. Just because I already had this prepped in my head.
We all have it.
GitHub.com/jmarlin. There is a operating system there called P5, which I have no idea why it was named that. I started doing it when I was 15.
Nice.
But that's my contribution to the
mine's
world of OS dev here. So
github.com/Wizard of Hass, my other internet alias.
All right. So check us out. Pull our code apart. Tell us how we don't know what we're doing.
Maybe don't pull my code apart. I am very fragile.
Leave him alone. Yeah. Don't. We'll bleep that that GitHub URL out. But yeah, so to what extent? I mean, presumably you're like writing x86 stuff because that's what everyone does, because that's what one has.
It is.
So like how
is correct.
Yes. So like how deep are we going? Because P5 off and on. I will say the thing that got me into it, and this is again, we're like off on a different. This has nothing to do with the episode topic, but I just wanted to twist your ear. So for P5, I guess as a child of the 90s over here, I see a GUI, and that's an operating system, right?
Yeah.
And then I go, okay, so how do I make that? How the heck does that work? And then you spend, the next umpteen years trying to figure it out, and then you're like, oh, okay, that's the easy part.
Yeah.
So anyway, P5 started out as I wanna write a thing that does GUIs, and then I had to write a kernel to make that happen. So I got like task switching working. I got a very simple drawing lib going. I started doing USB, and I could never get it to work just right.
Well, that kind of hardware stuff sucks, especially if you're in protected mode. So I got into it in high school because I was trying to become a better programmer, and I'd already learned. For some reason, it's a much longer story. Lisp was the first language I learned, which I don't recommend that.
Oh my God.
Awful path to take, but it is a path. Still an awful Lisp programmer. But in high school, I decided, I'm going to get better at this programming thing. Well, to do that, I should learn assembly language. And what am I going to write in assembly language? Well, I should probably do an operating system, because that'll be everything, right? I have to write everything myself. And so I made an account on the OS Dev forums, if you're familiar with osdev.org.
It would be hilarious if we ran into each other.
We may have.
I have no idea.
I ran into Terry A. Davis on those forums a few times.
Yeah.
To give you an idea of the era.
Yep. No, I understand. I think a whole bunch of us just got this interest all at the same time, because there was definitely a flurry of activity.
There really was. Part of it probably has to do with like Mike OS and like good example code for x86 being out there. But anyway, so I started writing. I prefer real mode just because it's fun. It's like more simple.
Yeah.
Well,
but segmentation though.
Segmentation's awful. I just rewrote my memory manager with segments, and every time I touch segs, it's just not fun. But the operating system I ended up writing, I did a megalithic kernel. So speaking of embedded, it's basically a binary image that gets loaded, and had a safe language, a really simplified safe language for application level stuff. There wasn't really much of a user land because of that.
So was all of your application level stuff was interpreted basically?
In theory, I think there was like a DC clone, so you could do like really simple calculator stuff. But I had cooperative multitasking in it because there's no memory protection, right? So, real mode stuff. And I had a really simple GUI, like 640 by 480, not very complicated at all, but neat. It could do, like, you could open a window and it would do a bouncing ball demo, and there was a terminal shell
sometimes
demo.
That's all you need.
It was fun.
When you finally on projects like that, when you get to the point where the ball is bouncing on the screen.
Yeah, exactly.
You've made it. Because it's just a gigantic Tower of Babel of things that need to make that happen.
Well, and you have to build up so many lower level things to get there. I very much stand by, if you want to get better at programming, try writing a hobby operating system, because then you have to write everything that you ever need to do. So I did that in high school, and then I made a 64-bit version of it. I did a little bit of work in C for another kernel. About every winter when it gets cold outside and I'm stuck indoors and can't go hiking, I end up going back to kernel development. So like this time I'm doing a nicer memory manager, and I switched calling conventions to use stack instead of registers, just that kind of stuff.
Yeah,
learned how to use macros more aggressively last winter, which was good. But it's just fun. It's like it's kind of like having a little Rubik's cube that you get to pick away at every once in a while.
Mm-hmm. Yeah, and you immediately know when it worked because it works.
Well, because it does
That's
something.
the pro. Right.
What I messed up on right now is I'm doing a loader, and it keeps loading and then returning to my kernel and dies, and I don't have debug hooks set up correctly. So I'm like, oh shoot, I need to actually use a debugger. I need to see what CS is set to, and I just not
and it's gone.
Energy. Yeah.
Debugging
in a virtual machine is tough if you don't have
your and debugging at that low of a level too.
Well, I mean, I
because like on an OS, like if it dies and you haven't put in good hooks, like you just lost the state, and I wonder how that happened.
I just need a button that shows registers. Like I right now I just need to see what CS is when I jump back, because I'm pretty sure that's wrong. I can't run my own debug routines in kernel to find out if that's wrong though.
The big one that got me this episode was, because this does link back to the episode now.
Yeah. Link
is
oh
no. And it is about links in the circular linked list known as a deck. And that's one of the OS dev hook here was, I think that's just somehow that's one of those everything evolves to be a crab. I don't know if you know that running meme.
Carcination.
That sounds right.
Like that.
Everyone writes a memory manager using links between free blocks is somehow.
Yeah.
Because I do not remember how. I mean, you could just go and look, but I'm not going to do that right now. Someone let me know how P5 does memory management. I think it's similar though. But I just thought that was a hoot. Is that's everybody comes up with that somehow. RSX did it.
I mean, it makes
to be sense. Fair. I think that's how, that's not like an unreasonable implementation for
not at all.
Memory manager. I think there are a lot of malloc implementations that basically do that.
Lisp uses the same mechanism essentially, except singly linked and not loop. The weird thing with RSX is the double link in the loop is like a little bit over engineered. For what you strictly need. But yeah, like you were saying, everything goes back to linked list. You can implement any data structure you want with a linked list. It's basically free. You just do it.
And I will say, here's an aside on the I do have one of the, hey Sean, but here's the thing, the overhead, and of course this is not going to be true for RSX. The cool thing to do is that you just keep track of the free blocks, and you use the unused space in the free blocks to store your pointer to the next free block.
Yeah.
And then you can infer the interstitial. There's allocators that do that too. I just thought that was a fun aside. Question on that, as far as the deck thing.
Yeah.
Is why is it circular? Did you understand that in your reading, or
is
it just because it like uses a clock kind of algorithm to like it just always is pointing at the next free space to start looking at looking for free zones? Or
the manual doesn't explain why it's circular. In a lot of these things, if you just have a manual source, there's no explanation as to why anything is the way it is, and this is how we implemented it. Yeah, this is just how we work. And I couldn't find any information in oral histories or interviews that said, oh, well, I just love circles. What's weird is in a deck, an empty list or a list with one element is just a node that has the next and previous pointers pointing to itself.
Mm-hmm.
I think if we're looking for a why, it might be around that, because the manual explicitly shows here's a big deck, here's a little deck, here's a one node deck. And if I could infer anything, if I could wildly speculate, it might have been done to make it easy to identify a single node that's isolated. But at the same time, you can just have null pointers, and that would do the same thing.
Right.
Right. So, I don't know. It could also just be in assembly language. Sometimes it can be annoying to have special cases to check for nulls. So maybe they were doing that so they wouldn't have to have like guard statements to prevent something from jumping off into a null pointer.
Right. It's always linked to something. And then
it's always linked to something. So you never have to say, oh, make sure the pointer's not 0 because then that will kill me. But
yeah, that's totally fair. And especially working on older systems with limited memory, I'm sure just not having as much code.
Yeah, not having as much code. Cases. Exactly. It's just weird because like I said on the episode, in my experience, it makes more sense just to have it end with a null because you can be like, oh, that's a 0. Why would I have a block at 0? So done. Yeah. Not going to look there. But the issue with that implementation with the 0 pointers is then you can't have a block at 0 because that would be considered invalid by the algorithm. And
that's fair.
I don't know where RSX in that period would load into memory, because if it doesn't load at 0, then it would be valid to have a partition that starts at 0, and that could be your deck partition. So you would have to have a node, or you could have a node at 0. So that could be.
So you specify where all of your memory segments are.
Yeah. So
in your setup
during system
and any of them can be a deck.
Yeah, you have to specify partitions, and you have to have a free space partition for decks, at least one, and that could conceivably be at 0. So I guess that there's an explanation. Let's go with that. It allows a node at address 0. I don't know why you do that though, but
fewer edge cases. There you go. Yet again.
Yeah.
Yes. Anyway, fascinating. I mean, memory management is, you said it in the episode, that's like one of the big bread and butters of the operating system.
Oh, yeah. Well, it's the bread and butter of so much programming in general is, I'd love to have an extra kilobyte. How would I get an extra kilobyte right now?
And I love it. It makes me think of like early days memory management. Because again, this is an interesting period, specifically that transition from like the 60s into the 70s. I mean, they're all interesting periods, of course, but they're all interesting in their own ways. And the 60s into the 70s is kind of like this. I feel like that's the era when things are starting to all of a sudden become like recognizable. You know what I mean? Like we've developed the theories, and now everybody has actually like communicated them and understands. This is basically how we do this.
Byte until we get into like that period, right?
Yeah, that's wild. Absolutely wild, that one. Yes. So in that vein, memory allocation and stuff like that in general is such an interesting thing, because kind of before that period, you've got I tell my juniors at work, I have specifically given them talks about this because I find it interesting that like I love that original Fortran. Oh, and now I'm not going to remember. I did a whole talk on this, but that Fortran didn't have any dynamic memory to it.
Yeah.
Until like the 80s or something. It might have even been later. There was no way to allocate memory. You just every single variable is allocated like in a data segment when the thing's compiled, and that's what you have.
Fortran 77 does have dynamics, because I've written dynamics in Fortran 77. But
of course you would have written Fortran. I like how I'm over here like, have you written Bliss? And then like, whoa, you've written Fortran professionally.
Yeah.
All right. So what was that gig?
The deep lore is what you're getting at.
Yeah,
I see.
Yes.
I had an internship, so I guess semi-professionally, where I was working out of the SETI Institute on hardware at NASA Ames, and so I got to write and maintain some Fortran software for their supercomputer. It was in
this immediately 77. All makes sense. That's Fortran world.
Yeah, no, all supercomputers are Fortran. If you have any illusions about that, perish the thought. That's how science works. It's not Python for Viz, Fortran for actual math, though.
And you know what? you know what makes a program really fast? Zero allocations.
Yes. Well, it makes a lot of sense because back in the day, like if you have an IBM 1401 or something, right? I guess like a 709, you're just running that Fortran program. Like what else are you going to run? Mm-hmm. The Fortran compiler. You're not going to run both at the same time, though. So there's no reason to allocate core because you get all of it.
It's allocated. You have
machine. Yeah. That's why you have to have someone there ready to pull the big red lever when your time is up and load in the next program. That is the allocation. Yeah. That is the allocation.
It is funny. Algorithm. Allocation. Yeah, allocation only makes sense in the context that you're doing some kind of multi-programming because otherwise you own everything. I mean, that's literally that's what old DOSes do is they MS-DOS just allocates to COM programs, it just allocates all memory and you have to request to release some of that memory to allow like a TSR or a subsequent program to load. Memory allocation is it's a bread and butter thing, but of course it only exists as a concept if there's someone you need to share it with.
That leads to an interesting question though. I wonder when the first memory allocator was actually written, because it's probably not in an obvious place.
I feel like it comes back to, because you kind of you started to mention Lisp as an aside there when we were talking about
memory allocation.
Memory allocation at some point back there, and allocation algorithms or structures, and like that's got to be one because I mean Lisp is ancient, and the core of the system is const cells, and that's kind of that's one of the things that makes memory management for Lisp and garbage collection for Lisp kind of easy-ish. Is your whole memory is uniform const cells, right? Yeah. So like you don't have to check for particular sizes of free blocks or whatnot. You just, if there is a free block, you can put a const cell there.
So
that's always been my assumption that like not necessarily with Lisp, but generally with more early like dynamic programming languages, or even those kinds of things that were research things that like weren't necessarily programming languages, but research interfaces.
It could have been some of Lisp's direct predecessors, right? Because Lisp's defined in 1958 because there aren't good Lisp programming languages, and then it's implemented in 1960. But previous to 1958, there's IPL, which is like Lisp centered assembly language kind of. That would
I looked up IPL after like the first episode that you mentioned it, and it is horrific.
Oh yeah, no, like
it is horrific.
You want to talk about
let's move on.
But languages.
Jesus.
There's also Fortran Lisp programming language, FLPL, which is it's not a language, it's a library for Fortran that let you do Lisp processing. I don't know if that had dynamic allocation though. If it did, it would have to be done in like some kind of back assward way that wouldn't be good to behold.
Right, because again, that's pretty early, so
yeah,
having any kind of, if you're starting with a base level of a Fortran compiler and then glomming something onto it, you'd have to really overcomplicate things. No, you just pre-allocate a gigantic array.
Pre-allocate
and then
everything. Well, it would probably have.
I mean, I guess you totally could.
You wouldn't have to do that. You can link out to assembly routines in Fortran. So it would have probably just had an assembly stub to be like, give me all the memory or give me an address. But yeah, I don't know. I should look into that because I'm sure there's some weird. It's probably one of those things that was invented like 3 or 4 times by accident just because it's so basic. But like at one point it would have been a next step that would have had to been taken.
So one thing that we haven't touched on a super huge amount is, I mean, all the way back up, we could start talking more about the what is an operating system question and how something like RSX.
They don't exist.
Operating systems are they're a construct, bro.
Yeah.
It all exists in the same memory. I think that's what I was getting at, especially with the library idea when I was saying that your operating system is more, you can think of it as a library because it's like your program is getting, especially like Windows, right? Windows is just built out of DLLs. That's just how it works. And so your program is just one of those DLLs that happens to have its own address space and it's linked into everything else. And one of the things it's linked to happens to be the operating system. So the other thing is like tasking. And one of the things I find interesting about RSX here is that it becomes multitasking. I'm vaguely interested, this will be a second bit to get into, where the multi-user part comes in, because all of a sudden by the end we just have, it is mentioned, it's also multi-user at this point. But the tasking makes sense at the beginning because you can think of a lot of those industrial systems as like they're replacing like relay racks to a large extent. So tasking,
yes,
it makes sense because you're basically running a bunch of stuff in parallel there, right? Like if you look at it as replacing
parallel,
like a but I'm saying you're replacing effectively a parallel machine of relays making decisions independently. You know, it's kind of the it's a bad analogy, but it's kind of that analogy between software and FPGA, right? In this case, you're kind of replacing an FPGA with software. And so it kind of intrinsically makes sense to me there that you'd want these little tasks, right? Like you want a task that is paying attention to this input, and you want a task that is, you know, altering this output on a regular basis or whatever, because those are your processes that you're simulating something happening that was previously happening in parallel completely. Whereas now you have to do it in a synchronous, shared sort of way. And so that's interesting to me because you end up with this RSX 11 at the end that has a user interface and it's multitasking, but it was never meant like it. Who's to say what something was meant as? Because also this is clearly one of those projects that it changes hands and a bunch of different people have different ideas for what they want to do with it, right?
Exactly. So there's kind of,
because especially at a big company like DEC, like that's
a loss of the thread at a certain point, right?
Yes, and the transformation of the thread into a whole cloth different piece of
right. So I think this is my conjecture that the multi-user thing comes in because of OS 45, which I think I only mentioned once in the episode. OS 45 was this aborted attempt to write a large operating system for the PDP-11. Think like, I want to say something like Unix, but also I don't know, because there's not documentation about it that I've seen at least. And that blows through all its timelines and fails. At the same time, there's a crew working on RSX 11D for disk. And that project gets prioritized as it becomes clear that OS 45 is dying. And OS 45 was multi-user. So I think that's why 11D ends up being multi-user. But also that information is from an interview with Dave Cutler where he like basically just says what I told you. That's all the information you get. There's not anything deeper. He doesn't even say, and well, it was the old system was multi-user, so we had to be multi-user. He just says, oh, we ended up replacing OS 45, and then starts talking about being multi-user, like a paragraph afterwards.
Yeah. So God knows on the multi-user for the multitasking though.
The multitasking,
someone knows,
though, is core. That's always been core.
Well, because it wasn't, again, to get back to the, like, wasn't intended to pick up back there. It wasn't started. It did not originate as, like, a, I don't want to say it didn't start as a multi-programming thing, because usually when you're using the term multi-programming, you're exactly describing this. It was meant to be multi-programming. Maybe not intentionally like let's do a multi-programming system, but like that is the goal. But time sharing, that's like, it wasn't intended to be a time sharing system. And so many of those like transition from the 60s to 70s, starting to get recognizable, like especially multi-user shared systems kind of stuff. It all comes out of that lineage of wanting to do this time sharing thing, right? All of a sudden that's a hot commodity. And I just think that's funny with RSX is that was not the point of RSX.
Yeah, it's kind of the
except in that it was to solve that problem for a completely different reason, and then it just happens to make the base for all of a sudden you could have this be the tasking model for a multi-user operating system.
Well, what you were saying about replacing parallel operations and circuits is very astute. Gold star.
Sometimes I get them.
Well,
I stumble right into them.
There's a thought process there, I'm sure. But what you're getting at is, the fact that computers are synchronous machines, but analog or digital circuits, non-programmable circuits aren't necessarily synchronous. So you have to have, it turns out you kind of have to bend a computer backwards to make it operate like an asynchronous circuit. And it also turns out that tasking model is that you have to build up for that is also really, really handy for things like having a keyboard and screens and buttons, right? Because, well, you want instant feedback, and if it's fast enough, or if it has like set constraints on response time, it can act as if it's instant, as if it's actually parallel instead of just going step by step and doing tricks.